Everyone, welcome back to my channel. Today in this video we'll be solving this question, insertion sort list. So let's read out the question first of all. Given the head of a simply linked list, sort the list using insertion sort and return the sorted list head. Okay, the steps of the insertion sort algorithm. So it's an insertion sort iterates consuming one element each repetition and growing a sorted output list. At each iteration, insertion sort removes one element from the input data and finds the location it belongs within the sorted list and inserts it there. It repeats until no element input element remained. Okay. The graph following the they have provided the visual representation of the question here. So as you can see, 4 2 1 3 can, if we sort it, then it will be 1 2 3 4. We have to use what that insertion sort technique. Like we can do this question using merge sort also, but they have told us to do using insertion sort. Okay, so we will use the insertion sort. And here you can see -153. It is in the sorted form. So the constraints are such that it's up to 5,000. There can be the number of nodes, and node value can be up to 5,000 minus 5,000. Yeah, cool. So let's see this. What is? I hope you guys already know about insertion sort. So let me, if you don't know, let me tell you what happens in an insertion sort. I will just give you a short introduction about it. So let's imagine this is you have number like this, right? And let's say 5, 3, 6, and 2, let's say 0. Yeah. So what happens in the insertion sort algorithm is that we assume that this first portion is sorted. Okay, let me tell you before that, let me give you the the core logic behind the insertion sort. So what we try to do in insertion sort is that we try to keep the left portion of the array sorted, and whenever an element comes up, and we try to insert that element in the sorted part of the array, which is in the left portion, in such a way that the left portion array, the left portion is still sorted. Yeah, this is the main logic. I hope you guys have played cards. So if you have sorted, I mean, if you have cards in your hand and this is, I mean, the cards are in the sorted form. So whenever you get a new card, you try to put that card in such order that the order is still sorted, right? This is what we do in while playing cards. So similarly, that logic comes up here. So let's see. This is 1, 5, 3, 6, and 2, and 0, correct? So I will assume that this one is up to this portion. Up to this portion, the array is sorted. Now 5 comes up. I'll check. Uh, what do you think? I have one where I need to be. I mean, where the 5 needs to be. To ahead of 1, definitely. So I will say, okay, yeah, put it here, right? Now this guy is completed. Like I'm completed for this guy, this guy. Now 3 comes up. What do you think? Where in this sorted list, I mean this portion, where the 3 needs to be? I think it needs to be in the place of 1 and 5. So what I will say, just swap it. I mean, just let's say do like this: 1, 3, and 5. I'm not going to maintain us. I mean, here you are seeing that I am just making another array, but I am going to do it in place. I will show you it later on. How will I do? Okay. So now 6 comes up. Now I will check from the front, or you can check from the back as well. It's up to you guys. So now I'll check 1. Definitely 6 is greater than 1. I mean the 6 is greater than 1. 6 is going to be on the right of 1. So I will check 3. It's greater than. I mean the 6 is greater than 3 as well. 5, 6 is greater than 5 as well. So I will append the 6 here. Right? Now 2 comes up. I will check 1. Oh, I'm lesser than you. Please move ahead. Now 3. Oh, the 3 is greater than 2, right? So definitely 3 is going to be to the left. 3 is going to be in the left. Okay. So where I will insert 2? I will be inserting 2 at the middle of 1 and 3. Yes. Now 0 comes up. I will insert it where? I will insert it here. 0, 1, 2, 3, 5, 6. This is how array is sorted using insertion sort. So let's try to try to understand this insertion sort using, I mean, in terms of linked list, how we can use insertion sort in linked list also. Okay. So let me give you another example. Let's take an example from here. Okay, let's take this one. 1, -1, 5, 3, 4, and 0. Correct. -1, 5, I think that 5, 3, 4, and 0. -1, 5, 3, 4, and 0. -1, 5, 3, 4, and 0. Yeah, cool. So let me take an dummy node, like an extra node. I'm not going to return that. I mean, I'll I will return the next of it. Okay, let me take it. Why? Because I really don't know which is going to be my start node. So for the sake of easiness, what I will do is that I will assume that I will assume. I mean, I hope you guys know about this technique where we try to create a dummy node. I mean, okay. So let's see. Let me have a value of 1000 like this. Let that node's value be 1000. Okay. So -1 comes up. I will what I will do is that I will place a variable here. Let's say temp, and I will check. Is there a next guy? Is there a next guy? I mean, I think I should have done something else. Sorry, guys. Uh, okay, let's say. Well, sorry, guys. I got confused a little bit. Okay, so it's -1. I will first check. Is there a next node? I found that there is next node. No next node. So what I will see, I will, what I will do is that I will insert this node at this position. Okay, cool. Now I'm done for this one. -1. Okay, now I will now the turn is for this fifth this node. Okay, now I will check. I will again place a variable here. I will check, is there a node next node? Yes, there is. What is its value? It's -1. So definitely I know one thing. I'm not going to be this node is not going to lie to the left of -1. It will be on the right. So what I will say is that so I will move this temp variable to the -1 position. Now I'll check, is there a next node? No, there is next node. No next node, right? So what? I will be inserting this 5 at this position because there is no next node. So it simply means that this is the correct person, right? Now I'm done for this 5 also. Now 3 comes up. I'll again place a variable here temp. I will again check -1. Oh, I'm not going to be here. I'm not going to be here. I'll place the temp variable here. I will find that the next node has a value 5. So it simply means that I cannot go to the right. I mean, the 3 cannot be to the right of 5. Okay, because it's lesser than 5. Yeah. So it needs to be to the left. So where it needs to be? Definitely here. So I will say I will insert a node in between -1 and 5. Okay. So yeah, like this way. Now 3 is also done. Now 4 comes up. Now again I will place a temp variable here. Now I will go up to that position where I feel like that until I don't get a number which is greater than or equal to me. Okay, until I don't get a number which is greater than or equals to me. What is the correct number? Which is 4. So what I will check, is there a next node? Yes, there is a next node. What is it? -1. Oh, you are lesser than me. Be back, bro. I will say, okay, get back. Okay, I'll say get back. It's now time. So I'll move to the next guy. Now I am here. I'll check the next node. What is its value? It's 3. So definitely this node is going to be on the left of side of 4. Okay. And now I'll say move. I'll go to this location. I will check what is the next node value. It's 5. Oh, so it simply means that the 5 is greater than 4. Yeah. So what will happen here is that the 4 value will be inserted here, right? I mean the while loop is going to stop here, and what I am going to do is that I'm going to insert 4 here, like let me tell you. I mean, so I will say what I am going to say here is that temp. Let me take out the location of this guy first of all. Let's say this is next node. Okay, so next node is equals to what? Temp dot next. Yeah, okay. Now I have to say I want to attach 4 to 3's next. Okay, so I will say temp dot next. Temp dot next is what? I will say temp dot next is equals to head. Let's say this is head or node. You can say anything. Okay, let's say head. So and at the same time, head dot next is going to be what? Head dot next is going to be next node. Why so? Because I said 3's next should point to 4. Okay. Now I say what I have to do. I have to connect this. I said 3's next point to 4. 4 next should point to what? 5. Yes, that's right. Now this is the code I will use for that, and I will say yeah. Now for 0. Okay. Now I'll say from temp here. I will find that the this value is lesser than me, so definitely this value will be to the left of me, so I will say okay, I will move temp to the right. Now I will say it's a 3 to the right of it, it's a 3, so definitely what's going to be is that 3, this 0 cannot be to the right of 3, it will be in between this. Okay, so yeah, I will connect a 0 and a 3 like this. So the final sorted array is this: minus 0, 1, 0, 3, 4, and 5. So let's see answer: minus 1, 0, 3, 4, and 5. So let's move to the coding part, guys. Let me check if the head is not going to be null. Yeah, so the number of nodes in the list is in the range 1 to 5000. So head is not going to be null. So I don't need to check for that. Okay. So let me, as I said, I'm going to make a dummy node. Let's say it is dummy equals to new list node of value what? Minus 1. We can keep it anything because we are not going to return this thing. We are going to the next, whatever is into the next of it. Okay. Now I'm going to process what? I'm going to process each node. Okay. So I said while head is not equals to null. Correct. So very first I will do is that I will process for this minus 1 node. Okay. This first node, this is minus 1. Now what I said, I will go up to that position. I will move my temp variable up to that location where I said until I don't find a value which is greater than or equal to me, right? I hope you understood what I said earlier, right? Just few minutes back I told you that logic. So let's say temp is equals to head. And one thing, guys, after if you remember that I'm connecting each node. Okay, like this minus 1 comes up, I'm connecting with it. Okay, now after connecting, what is happening is that I'm losing the information of the next node, so I need to store the information of the next node also, because in the next iteration I will be solving for this node. So I will save it in somewhere. Okay, I will save it in a variable. Let's say it's next head. So the next head is this head next. Correct. Now where up to my while loop will run. First, let's say temp dot. Is there a temp dot next? And is the temp dot next dot val is lesser than or equals lesser than the head val? If it is, then let's say then what we are going to do is that temp is equals to temp of next. Now what I'm trying to do here, let's understand this. I have already explained you this, but still I will teach you it. I think I can do like this as well. No, it's not okay. So let's minus 1 uh, this is minus 1, 5, 6, 8, yeah, 9, let's say. Okay, now I have a number 7. So up to, I will start temp from here, and this temp will move up to where? It will move up to when? Until I don't find a number which is greater than me. So I will check the next number, which is what? 5. I will say, okay, move temp to the this position. Now temp is here. Again, I will check the next guy, which is 6. I will say, okay, I need to be here. Now I will check the next guy, but I found that it's 8. So it simply means that I have to stop here. I cannot go further because 7 cannot be to the right of 8. Okay, it needs to be to the left of 8. So I will stop here. Now what I have to do? I have to simply use this code, right? I am connecting. I mean, I am inserting a node in between 6 and 8. It's a simple code, yeah. So let me take out the next node first. Next node is what? Temp of next. And at the same time, now I'm going to say temp of next is equals to head, and head of next is equals to what? Next node. And what will be my head now? See, my head will be next head, right? I'm going to process for the next item now. So head equals to next head. So now I can return what? I'm going to return dummy's next. What is the time complexity? It's simple O of n square. And space complexity? As we are not dealing with any extra space, so the space complexity is just O of 1. So let's try to run this. There's an error. Guys. Oh, sorry. I think I did a mistake, and that is the temp should be started from dummy, right? This is a tiny mistake I did. Now it's correct. So let's submit it. Submit it. So I hope you guys understood the solution. Thank you for watching the video.